What I want to look at this video is scatter plots, like looking at linear relationships. So we're looking to write an equation of a trend line for real world data, use the line of best fit to make predictions, calculate correlation coefficient for the linear regression, and interpret what that means in terms of the data. Whoa, a lot of like big math terms there. Like I'm looking at like linear regression, right? Let's highlight that one. Um, Calculate correlation coefficient. Like, what in the world is this? Making predictions. Okay, calculate and interpret what that means in terms of the data. So this is kind of a big point too. I'm going to highlight this, but a little different color because I'm not really necessarily looking at the vocabulary. So what in the world is a linear regression? Well, that's going to actually be this. I can write an equation of a trend line and line of best fit. So like this equation that we write is the linear regression. And let's try and make this correlation coefficient. Let's make that a different color too, not green. Let's go with blue. So use the trend line and line of best fit to make predictions. So we talked about that. Write linear equations that model real world data. That's the only thing we're going to be doing in this video. And then make predictions. So we'll talk about correlation coefficient here in a little bit. But in here, you can kind of see over here, I have a graph in Desmos right above the picture of me. So I think I can kind of move that around, but I don't need to. I can leave the picture of me there. You can see that I have all this data in here. These are called residuals, and you can have like parameters. M and B are exactly what you expect in an MX plus B. And this R value is going to be, this is your correlation coefficient. I don't think I can actually highlight that. Maybe I can use the pen feature and make it blue and kind of say right here, this, right? That value would be your correlation coefficient that would respond to that piece. All right, so what exactly am I going to do over here? Calculating and interpreting lines of best fit. So this is the work I'm going to do in the video, but first I want to go over the work I already did. So you have your regression line, right? We talked about a linear regression, the line of best fit. That is this line here. This is the equation. I have it in slope-intercept form, y equals mx plus b. So, and I used this data here, weight and number of tackles. So you can see this data is over here, 235, 207, 197, 205, 250. So it's the same data from this table, and the tackles are there too. There's this extra column, which is our residuals. We'll get to that in the next lesson, what that means. But for this lesson, I'm just focusing here on this and this. And then you have over down here, you have parameters M and B. So I'm able to get this, fill in this formula and run this linear regression where it gives me this M and the B. So I just basically fill that in and I round to the nearest thousandth. So I'm just going to we'll keep that a standard procedure. You round to 3 place values in your decimal or tenths, hundredth, thousandths. So I said y equals 0.515 or 0 and 515 thousandths times x, which is this number right here, rounded to the nearest thousandths. And I did minus, normally you do plus b, but I did minus because b is negative. B is a negative value, minus 70 and 216 thousandths because the force is to round down. So you can actually see this graph here. Can take this out. So you can see these are the points of the weight for the number of tackles, and you have this line that kind of shows how that would look as a potential equation of kind of a prediction of if you weigh this much, how many tackles do you be? So then if you look at your slope value and interpretation, so your slope here would be what would I multiply by the weight to get the number of tackles? So this is basically, the slope would say for every pound of weight you gain, so every time the x value increases by 1, you're going to multiply that to kind of figure out, you would make about 0 and 515 thousandths more tackles for every 2 pounds you make. So you make about half a tackle more for every pound, or for every 2 pounds, if you double this, you make about 1 more tackle. And that's how you would interpret your slope. We're going to make a second video here to go over the kind of how I did the rest of this data.